Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome to ARC's FYI podcast. That's For Your Innovation. Sam Corris, I'm one of ARC's industrial innovation analysts. Today we've got two great guests. We've got Tyler and Colby Stilson of Operos Manufacturing. Thanks for joining us today.
Absolutely. Thanks for having us.
My pleasure.
Could you just go into a bit of background about who you are, what Operos does? And I think, our listeners will be really excited because we invest in automation and manufacturing a lot, and there's tons of people who speculate on it. But now we have the opportunity to speak to people who are on the ground actually doing it.
Yeah. So a little bit of history of Operos. I first started in the manufacturing world in 1997, working for my uncle in what's considered a job shop. So basically a job shop comes down to high mix, low volume manufacturing. And my uncle's shop was all machined parts. So we didn't do sheet metal. We didn't do injection molding. We didn't do wire EDM or conventional EDM. We were all machine parts. And the day I walked in the shop, I knew that this is an industry that I wanted to be a part of. There's a lot of reasons why, but the main one is I've always appreciated making things and knowing how things are made. So it was very interesting to me in the very beginning. And you could see the potential in this industry back in the late 90s when I started for automation. Technology is moving much faster in the last 2 decades than it was in the previous 2. And there's manufacturing, I always felt like was more or less the backbone of our economy. And as I got towards the end of high school and into college, where we grew up, we didn't have a lot of exposure to manufacturing. So it was all new to me. I guess I didn't know what I didn't know until I got into it. And I guess fast forward 10 years, we started Operos Manufacturing in 2007. And part of our original business plan was to work towards implementing automation into our company because it was really hard to find skilled labor at that time. Most people were going into 4-year college degrees and moving on to industries outside of manufacturing. There wasn't a big drive in any of the schools around us for manufacturing. So one of the ways to fill that productivity and skills gap is to automate. And it took us a while to take the first step into automation because it's a lot more expensive than just your standard CNC machine tool. But we have slowly been kind of incrementing and iterating to get to that end. So that's where we are today.
Great. And I want to dig into that. And Colby, let's get some of your background.
Yeah, so I took the 4-year college degree route that Tyler mentioned and went into the investment world. I do similar things to you, Sam, and have recently transitioned into being an entrepreneur, similarly to Tyler, but just in a different space. I invested early on in Operos and in my brother and have a similar passion for technology and how things are made and machine shops more broadly. And I would say that, my experience of observing Tyler and Operos is that this is truly an example of a company forged in crisis. This was right before the great financial crisis was the opening day for Operos. And so it was really a time of a need for innovation and a need for survival in a lot of ways. And I think it shaped the strategy and the approach that Tyler's taken with Operos in a lot of ways. I am an advisor and an investor in Operos and a keen observer.
Well, you can't beat that timing for starting a company, but we do say innovation takes hold during these times of turmoil because you need to find ways to do things cheaper, better, faster. Since you've been in the industry so long, Tyler, what does it look like in the shop what does automation mean in a job shop from 1997 to 2020 now? What types of things are changing?
I guess if you go back a little bit further to when machine parts were done on manual equipment, and as we call hand crankers. You got a guy in front of a manual machine, and he's literally turning axes with a handle and machining parts. And then CNC machines came into the picture. And at that time, that was considered automation, and still is. I would still look at that as a step towards automation, because you're taking the hand cranking out of it and it's now computer programmed machine tool. And a lot of companies were very scared of taking that step. And the perception even then was that automation is going to replace people. And to some effect, I guess it did, but more so, I think it made people much more efficient and much more competitive. And it also started to make the industry a little more desirable to the upcoming generations. We didn't really grow up with computers. Our kids certainly have. And now that's a part of the world that we live in. Everything we do is hooked up to some kind of computer technology. If you take that a step further, in 1997, we had a regular 3-axis vertical machining center that we bought with a pallet changer. So when the machine stops, typically an operator's got to open a door, loosen a few vices, change some parts in and out, put new parts in, retighten the vices, close the door, hit go. And so that downtime, it's basically lost time. And it might take 2 minutes, it might take 5 minutes, it might take 30 seconds. And with a pallet changing machine, the machine will automatically pull a table full of fixtures or vices or parts into the machine and start running operations while the operator is changing parts over on the other pallet. And so you start to maximize the machine's efficiency and you eliminate some of that downtime. That's kind of what it looked like in the late 90s in my situation in the shop where I worked. And then we bought what's called a screw machine. So it's basically a lathe that makes round parts. And it's a little more complex than that, but effectively it makes round parts. And you feed this machine a 12-foot long bar, and it will run the entire 12 feet while when it finishes a small part, it drops it off into a chute, and it will run overnight unattended. And those types of machines have been around for a long time. Probably 30 years. But for some reason, not a lot of shops had machines like that, and people didn't really view those machines as taking jobs away. I'm not sure why, but that started to make its way into regular CNC lathe machines where you can add a bar feeder and you can put a 3-foot or a 4-foot or a 12-foot bar on a lathe, which is a bigger machine making bigger parts, and run that unattended. There was a huge benefit to that. And then if you take that to a CNC machining center, which is not making round parts, it's making square or rectangular, different shaped parts. It's harder. You can't feed a bar into a machine like that just because of the way that it works. And so you start looking at pallet changers, where the machine itself will pull a table, a fixture in and machine it, like I was talking about earlier. And you eliminate the downtime when an operator stops the machine, opens the door, and changes out parts himself. And today, what it looks like, one of the machines we have is a vertical 3-axis machining center, and then it has a 5-axis rotary table mounted to the machine inside. And right next to the machine, mounted to the outside, is a robot. And right next to the robot is a carousel that you can load 60 pallets. So you can basically put 60 fixtures with any kinds of parts that will fit in the work envelope in this carousel. And you can program it to run different parts of the same parts on each fixture. And then you can really walk away. And this machine will run overnight. It'll run all weekend. It depends on the parts that you're running and the cycle times. But the big benefit to that for us is we have one of the hardest things is finding skilled labor. We try to pull people out of tech schools, hire them right out of tech school. But then you're getting guys that are still fairly green. They might be familiar with what a CNC machine is and what different kinds of tooling looks like. But when it comes to the application in an automated cell, you're pretty much starting from scratch. And the technology in job shops is kind of, not a lot of people are doing it because it's so expensive and it takes like another level of programmer to program the machines as well as set them up and really understand how to utilize it the right way. And it all comes down to just being creative. These machines are so capable now that I feel like the sky's the limit, and sometimes bringing in somebody that has no prior experience is the best way to go because they come up with ideas that are like crazy. 20 years ago, you would never do something like that. But with the technology today, we can. So we go through these iterations with people and with machine tools. I don't know, I feel like every day almost we're learning something new and we're figuring out something new that we are capable of doing. And it's really exciting. That's the direction that we're headed as we move forward.
Before we go further, I think anytime you mention automation, and you mentioned it as well, right? People talk about jobs, job displacement, lack of skilled workers is another component, and just the way that these jobs change with automation. We've done a lot of research where we think automation, due to the productivity boost it gives, can actually create new jobs, more jobs than it displaces. What are you seeing from your side of things?
I totally agree. I don't think we're eliminating jobs. I think we're providing better jobs, higher paying jobs, more productive jobs. And at the same time, I think we're making the industry a lot more attractive to the upcoming generations because we're adopting this technology and we're deploying robots that are programmable by the average guy. You don't have to be a crazy engineer with 10 years of schooling to deploy automation in a machine shop anymore. And so I would agree with what you said. I think we're creating jobs by adding this automation because the fact is we can't find people anyway.
I think about that question even more macro. Tyler and I always talk about this concept of machinist 1.0, machinist 2.0, and 1.0 being the guy that was pushing the buttons, opening the door, taking the part out and replacing it. That US manufacturing model was largely displaced by offshoring because labor costs away from America were lower. And so we saw a lot of manufacturing capacity transition in that way. Whereas now, today, with automation, Machinist 2.0 is your programmer, your guy that's going to be thinking creatively to the extent that Tyler's articulating. That provides US manufacturing, from a macro standpoint, a huge growth opportunity to take back manufacturing. And I think even more imminently, today's environment, COVID-19, is accelerating the future in a lot of ways and creating a lot of dislocation in global supply chains that are going to draw a lot of people much more locally and regionally, which provides even more opportunity for this Machinist 2.0 and technology to grow just macro.
Well, I think that's a great point. And again, you started right before the 08-09. Now, you're seeing that boost again from this COVID-19 crisis. But when it comes to installing automation, the way that it's framed in a lot of consultant reports, right? You have an industrial robot, you buy it, but then it takes 3 months or maybe more to actually integrate it into a production line and get all of the safety barriers and stuff up and running. What is the actual process? You can't just buy a robot and plug it in and make it work, even though that's kind of the trajectory of where we're going. What goes into actually automating away from just the buzzword of automation?
So I think it depends. If you're talking industrial robots, it is a lot harder than it looks. You can't just buy one and plug it in, as you said. Typically, you've got to get an application engineer involved. And we're in the middle of this process on one of our machine tools right now. We have the robot. I've got 3 guys that understand how all of the I/O works between the robot and the machine tool. They understand how the electrical panel in the machine tool works as well as the robot. But the disconnect is we've never actually hooked the two together before. So we're learning some of the smaller details that we didn't know. We don't want to reinvent the wheel. We could buy the books and we could go through it and we could make our mistakes the same ones that they made when they developed them. But we'll hire a third-party integrator. And so they'll probably spend, once we get the robot physically next to the machine mounted, we'll have all of our tooling and fixturing ready to go. We've got to run pneumatics or hydraulics for the fixturing in the machine so that the robot can transfer parts. So we'll get all of that done. And then we will have a third-party integrator come help us write the robot program. That's not something that we've gotten very deep into yet. So they'll help write the robot program. It's a different type of programming. It's more machine logic than it is XYZ Cartesian programming. So it'll probably take 2 days, we're planning, to get the robot programmed. And once that's done, they'll basically allow us to watch over their shoulder. We can take pictures, we can take notes, we can ask questions. And our hope is that after we go through this once, the next one we do, we can do it ourselves. And it may take a few phone calls, but we won't have to bring in an integrator. And that's the direction that we want to go with our company. Is we want to keep deploying robots to machines, but we want to have the ability to do the integration ourselves. So we're going through that learning curve right now.
And have you looked at some of the collaborative robots that are out there? Obviously, much lower specifications as far as ability to lift things or precision. But you're right, they're trying to aim for that solution of, no coding, simple integration.
Those cobots, they're super cool. I think there's a lot of applications where they would work really well. I guess the only unknown we have to that is not being an industrial robot. I don't know what the lifespan is when you plug them into a CNC machine environment where there's fine chips, there's oil or water-soluble oil. It's not a very clean environment where the robot is going to be working, at least when it's inside the machine tool. And from what I've read, that's one of the downsides of the cobots at this point. But the other issue is you still have to do some integration with the machine, because when the machine is done running a part, you've got to hook it up to the robot so that it tells the robot, okay, it's your turn. And then the robot does what it does, assuming it does it right. When it's done, it tells the machine, I'm done, now it's your turn. The machine runs its parts. But you've got to integrate it to a level where if one or the other has a problem, maybe the machine tool alarms out, the robot doesn't start going in to change a part because the machine's not ready. It's not just turning a switch on. I guess I haven't seen a very good solution for that. I think what's coming is plug and play. So when you buy a machine tool, you can buy an option that has a plug for a robot and you plug it in. And so a lot of that integration is done because it's fairly simple if you just want the basic integration. But the programming of the cobots is amazing because you put them into kind of a relaxed mode. It's like an iPad programming platform. And you drag the arm of the robot over where you want it and you program a point and you tell it if you want to open or close or blow air or whatever. And then you drag it to another point, teach it, drag it, teach it. And within a half hour, you can have a robot programmed from scratch to load and unload parts. So that part of the collaborative is really cool. And I know that every industrial robot manufacturer in the world right now is working on their own version of an industrial collaborative robot for that reason. So, I mean, it's coming. It's not quite here yet, but it's coming.
And then just to take a step back, can you just walk us through from a very high level how Operos works from, I come to you with an idea and I say, I think this would be a good product. I want you guys to manufacture it. How does it go from that idea stage to finished product? Could you just walk us through the steps involved there?
Yeah, so typically we don't do a lot of consumer products or consumer orders. We're mostly B2B. If you take like an aerospace part, we'll get a 3-dimensional solid model and a print for a part. They'll typically email it to us. They'll have a quantity that they want. We'll upload the model. We'll go through the print and the model to find out if it fits. If it does fit, we'll estimate times that it takes for setup, tooling, runtime based on the quantities. We'll send them a quote if they like it. If they like the lead time and our price, they'll issue us a PO. And at that point, we go into production mode.
Hey, Tyler, you have dealt with consumer products and created your own at one point. I wonder if it would be worthwhile to go through that track for Sam as well, just in terms of, like the Oso barbell collar, for example. If you were to think about that as a customer that came to you with a product or a prototype and walking through that front end process, I don't know if that would be interesting or not, but I just wanted to throw that out there.
So you always have machine tools with extra capacity in a job shop. When you're not running high volume, there's always machines sitting, there's idle time. Typically, it's because you don't have enough people to cover every machine, or nor do you want to, because the cost is too high to have a person per machine. So we've always thought that it sure would be nice if we had our own product that we could run on machines in the background. Anybody could load these parts when they had spare time. And if the machine had excess capacity, we'd just fill it with our own stuff. And so we developed a barbell collar. And at the time, it was for the CrossFit world. The idea was to have something that held up to the abuse of repeatedly dropping a barbell from overhead over and over and over. We came up with some back of the napkin drawings and then went through quick, rough prototypes. At that time, we didn't have a 3D printer, so we actually had to machine our prototypes. And so we spent some after hours time machining prototypes, and it probably took about 2 weeks and maybe 6 iterations of this collar design before we had something that we really liked. And so we decided to put it into production. We picked one of the machines that had some downtime and plugged these parts in and made maybe 50 of them. And then we sent them out to get anodized. It's a plating process for aluminum, and put them together in simple packages. And then we sent them out to a handful of people that were in the CrossFit world at a high level. After about a week, one of these athletes posted it on social media. And the next morning, our email just lit up. I mean, we started getting order after order after order, to the point where we couldn't figure out what was happening. And we didn't know that somebody had posted on social media. Somebody actually called my wife and said, "Hey, so-and-so just posted your collars on social media." And we're like, "Oh my God, no wonder we're getting 25 orders this morning." So anyway, that product kind of got into, I think, the right hands at the right time. And there wasn't a lot of competition for that product at that point in the CrossFit industry. So it got picked up by a bigger manufacturer. And when they put it on their website, the whole thing just blew up. So all of a sudden we're adding machines, we're adding people, and now 50% of our business 6 months later is this product that we designed just to run. It was almost like a hobby product. You know, it was designed to fill excess capacity when we didn't have anything else to do. The hard part about it is when we're designing our own product, it's a lot easier because we can put the time into setting up a machine, working on weekends, buying material. And when you do it for a third party, for another person, you have to charge for that time. And a lot of people don't realize how expensive it is to make one part if you have to set it up and machine it. And then if they want to make a revision change, then you have to set up and machine another one. And making one part of anything is extremely expensive in a machine shop. It's almost like you have a good relationship with a new customer that has a brilliant product. You tell them what it's going to cost, and they think you're out of your mind. And so they disappear for a while looking for a better price. And then a lot of times they'll come back after they realize it's not a bad price. So the process takes a lot longer when you're dealing with somebody that comes in off the street, if that makes sense.
And so has this experience made you want to lean into 3D printing at all?
Oh, yeah, totally. We've got a 3D printer now if we come up with our own concepts, and we've done it for customers as well. If they have a concept, they want to prove the concept and they can do it out of plastic, then we'll print a prototype. We can do it overnight and we can get them something 2 days later. And then if they like the way it feels and looks, then we may move forward and make one out of, say, stainless steel or aluminum or whatever the final product needs to be made from. The 3D printing in that regard has helped tremendously in the product development. Because a lot of times when somebody develops a product or they think of something, it looks really cool on a computer screen. And then when you actually hold it, you realize it's horrible and you hate it. But if you just spent $400 to get a machined one, it's almost like you throw in the towel. And now you can pay $30 for a printed prototype and realize you hate it, make some changes, and then get another one. And it's a lot quicker.
One point you mentioned earlier was the underutilization of machines and just using that excess capacity. I think we can use that to kind of look at the larger picture of manufacturing in America. When you say manufacturing, a lot of people just think GE and auto companies fill their mind, when the reality is that most of the manufacturing actually comes from these small job shops, the ones supplying parts and actually making these small batch productions. What's kind of the normal duration of a project for you, and how's that look like?
So right now for us, it's the average is 2.5 days. We track the life cycle of a part when it starts in production to when it leaves production. And our average is 2.5 days. So in the facility that we have in Hutchinson, Minnesota, we've got, I think, 9 CNC machines and anything from a 2-axis lathe to a 5-axis pallet changing machine. But we don't have enough people to cover one person per machine, which is by design. The cost gets too high if you have one person per machine. And so a lot of times you've got one guy that can cover 2, 3, sometimes 4 machines, especially on a second shift where we're a lot thinner than we would like to be. So speaking, I guess, to the machine downtime, there's always a machine that has extra capacity. And the challenge for us is how do we schedule jobs in a way that we can cover as many machines as possible with as few people as possible, while at the same time, we've got to keep in mind we want to minimize our work in process. We don't throw work out there just to put it on a machine because the machine's open, which is a whole other conversation. I guess that's one of our big challenges is scheduling, knowing that we have a lot more equipment than we do people.
I guess the long-term vision for a lot of people in manufacturing is, right, lights out manufacturing, 0 people. How does that compare to the reality, and what do you think it takes to get there?
When I think about 0 people, I think about a weekend shift. You have 0 people on a weekend shift, but say your day shift on Friday loads up 7 machines with pallet changing cells or bar feeders or something like that, and they come back Monday morning and those machines are still running. In the real world, that's how you get 0 people on a shift, which is totally possible. And there's plenty of companies that are doing it. I think there's not a lot of job shops that are doing it. There's a lot of bigger, high volume production facilities that, they do it all day long. That's kind of their cup of tea. But it's coming in job shops. We're right there.
But there's programming intensity associated with that sort of a job shop model, right? Which will always incorporate human capital. And so I think that's the distinction between Machinist 1.0 versus Machinist 2.0.
And then Colby, from the business side, what does the business model look like for a small manufacturing company? How do you think about automation in enhancing that type of business model, or how does it change it?
Yeah, when I think about the 1.0 business model, it's an 8-hour shift and it's very manual and labor intensive. And it's also the skill set is simpler, I guess. I think in the 2.0 environment, the business model changes because you're dealing with things like automation and technology, and you're dealing with multiple shifts. You can span from an 8-hour shift to a 24-hour shift in some cases, per Tyler's point. And that requires program intensity, technology intensity, all of these things that are totally different. And so the human capital piece of that is different. I think there are operating margin opportunities associated with that sort of a transition. And there's also opportunity for people who are, graduating with engineering degrees to step into job shop type profiles to do the sort of creative, technology-oriented thinking that Tyler's talking about and that he's doing today. That's super interesting and provides, I think, huge growth opportunities. What I really like the idea of doing is rolling up old platforms and putting them onto a technology platform. And I love, Tyler and I talk about this all the time, love the idea of engaging the entrepreneurial community and having a business model that can take in a drawing on a napkin and articulate that all the way through the manufacturing process to a finished product that's then scaled and put onto a technology platform to go distribute and sell. We love talking about stuff like that.
What's the biggest barrier to that concept right now? Is it just going from napkin drawing to computer-aided design? Because it seems like once you get a good design file, then you can do what Tyler said. You can prototype it on a 3D printer if needed, or you can machine a part. So where do you see the barrier for that type of concept?
I think there are 2 primary barriers, and Tyler, jump in here, but I think the first one is scalability. So I think there's a lot of work that still needs to be done to hone that business model, to hone the technology integration with human capital. And then there's the capital intensity. These machines are really expensive and the integrations are still very complicated. So I think once all of those come together, where you have the operating business model established and the return profiles that are required for that level of capital intensity, I think you have something that's scalable.
And then I think an interesting thing that I wonder about is the manufacturing scene is composed of all of these disparate manufacturers. Probably the big ones talk to each other. When you're looking at new technology or what works, what doesn't, I think one of the things you mentioned earlier that's probably underappreciated is that all of this is being done for the first time, right? So you don't necessarily want someone who's done it the old way because they won't be able to think of or have new DNA, as we like to say, to think of the best solution. Who do you get inspiration from? How does that work when you're looking to automate or attempt new ideas?
So I think some of it comes from the guys that are out there selling these machine tools and the automation. And I'm not pro sales guy. There's a lot of times where you hear what they want you to hear. We've got a handful of guys that we really trust and we've worked with for a long time. And when some of this new technology comes out, they basically can kind of translate what their company has done internally, say with their applications department, to see what this kind of technology is capable of. So if it's a machine that has a 60 pallet pool and the pallets are loaded by a robot, they'll bring this machine in from the manufacturer, they'll put it on their floor, and they'll just start playing around with it so that they can start to learn, if we're going to sell this, we've got to figure out what's our target market. And if they are talking to somebody like Colby and I, we are for sure their target market, but they know more than we do about the application. So they can look at the mix of parts that we do, say the average size and the materials and the software that we use, and they can have a really good idea if it's a good fit or not. And at that point, typically they'll tell us, hey, I'm going to send you some information, just look at it, think about it. And one of the newest machines that we added a couple of weeks ago in particular has kind of been on my radar for about 2 years when the concept was developed. And I've been thinking about it. And finally, I called the sales guy and I was like, you got to be straight with me. Do you think this fits a shop like ours? And he said, absolutely. I think it's the perfect application. And what I'm finding out is he was absolutely right. But it was 4 times the cost of a standard machine. So it's a big risk. And it is a pretty big learning curve to figure out how to make all of the pieces work. But until somebody puts it on their floor and throws out some YouTube videos and social media information, we don't know anything about it. We can see pictures of what the manufacturers developed and we can kind of come up with a concept in our head of how it works in our facility, but we don't really know until we take that leap of faith, I guess.
And then when you're looking at the cost benefit analysis, what's that look like from your side? Are you looking at whether you can boost productivity by a certain percent, if you can reduce the number of people per shift? What's that look like?
So usually we don't necessarily look at it in terms of scale right away. We look at it in terms of what is realistically on our floor. What does our company look like today? And how does this affect today's operation? And the biggest benefit is boosting productivity without having to add people that we can't find. And every time so far, it's been a win. It's worked out. Usually number one for me, that's how I look at it. Can we get more productivity without having to find somebody to do that?
And productivity is across several paradigms, right? So there's just machine utilization, there's scrap, there are several different layers to that onion in terms of productivity.
Oh, for sure. You can have an automated cell that never runs lights out. It only runs while people are in the building just in case something happens. And you still see like a 20 to 30% increase in productivity because it doesn't go to the bathroom at lunch and it doesn't get distracted and it doesn't talk. It just works. There's a lot of scenarios where that type of automation cell is only run while the first shift or the second shift or somebody is there just in case there's an issue.
That 20 to 30% boost, I think, is very important. And one of the things I've been working on this recently to dimension is people underappreciate that you can get that productivity boost and that allows the company to have higher operating margins. And then Colby, like you said, you're going from machinist 1.0 to machinist 2.0. So wages can actually increase while operating margins are also increasing. It's not this job displacement and then job destruction. It's actually, you're just changing the type of job and increasing the amount that person can get paid while also improving the valuation metrics of the company?
That compensation is commensurate with the skill that's involved in operating the technology. And I would also say there's this demographic thing that's happening right now that we all know and love, which is a very big and old generation that's retiring. And so a lot of these baby boomers are in stages of their career where, they don't want to take risk like this. They don't want to relearn technology that they've been operating for 40, 50 years. And so that provides a real sort of near-term opportunity for that next generation, as Tyler speaks, to adopt that in the context of technology. And so the macro all the way to the micro, there's huge opportunity.
That's a great point. Tyler, what's the next piece of automation that you are looking at that's exciting you?
So right now, we're deploying an industrial robot to a machine here currently. I think the next step is to pick up one of the industrial collaborative robots as soon as they hit the market, which I'm assuming some of them have, but the one I'm really waiting for, should be September timeframe. It'll be available. FANUC, they're probably the biggest industrial robot manufacturer in the world right now. So you've probably heard of Universal Robots. They're the true collaborative. I mean, they kind of paved the road for everybody, but they proved that job shops and a lot of manufacturing companies can use that type of collaborative robot. And I think the big industrial guys realized that they better get on board quickly because the whole industry is changing around the world. So as soon as FANUC comes out with theirs, I'd like to jump on one of those, figure out how to deploy that to a machine, but not dedicate it to one machine. Our plan is to develop our own plug system and maybe put it on 3 or 4 machines so we can take this collaborative robot from one machine and put it on another one if it makes sense to be on there today, and tomorrow we can put it on a different one. That's the idea.
And then with the cost of collaborative robots, it seems like ultimately your shop would be dominated by more collaborative robots than large ones. Is that accurate?
Yeah, for sure. Ultimately, I think it makes the people that are here, it makes them a lot more productive, and it makes them, I think, happier, because every day is the monotony that, the part of the job that gets boring. They now are managing a robot to do that. And then they can do something that's a little bit more productive, a little bit more exciting. And if we can roll that out across the shop, that's one of the long-term goals that we have.
Colby, from your side of things, what do you see as the biggest hurdle from the financial standpoint, going from where it is today to where it needs to be?
I think it's the capital intensity. So we would love to be able to be in a position to be working on the scale problems. You can't even get to that point until you've put these machines on the floor and learned how to use them. And, he's my brother, so this comes easily, but Tyler is extraordinarily talented at that integration problem and thinking about the nuts and bolts of operations and CNC machining and the integration with technology. That's a very unusual skill set. And so I think it's finding the capital to make the technology happen, and then finding the human capital to make the integration happen. I think the way Tyler's thinking about overcoming that hurdle in some ways, once we get past the financial piece of this, the investor profile that's permanent capital, right? If you're growing a machine shop, it's very capital intensive. There's not like an ROI profile over the near term. It's a very hard business to grow. It's very rewarding and it's very interesting, but it's permanent capital type investment profiles that I think you have to engage. And then on the operational integration side, I think what Tyler's contemplating as it relates to cells and creating cells around these machine tools and then leveraging that across a system, I think that's a very interesting way of effectuating that integration.
Thank you both for joining us today. It's great discussing manufacturing and where it's going. How can we follow Operos Manufacturing and keep up with what you guys are doing? We
are on LinkedIn. I'm a little more active personally on LinkedIn. Occasionally we will be on social media. I think it's Operos_MFG. I guess that's part of the next year, is to be a little bit more active on the internet. Websites, operosmfg.com, as well as 3dcnc.com.
That's right. You got to be the one out there teaching us all how to use the new collaborative robots. Get a little educational series out there.
Yeah. Well, as soon as we learn how to do it without messing it up, we'll definitely share everything that we can.
Look forward to seeing it.
Thank you, Sam. Great talking to you.
Yeah, thanks for having us.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions, and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.